Hello everyone, I am your mathematics knowledge coach Vivek, and in today's class we are going to learn about exponents and powers. So, as you guys already know, what is an exponent? So, exponent is nothing but a repeated multiplication of any number. Now, let's say this is nothing but 2 to the power 3. So, 2 is multiplied with itself 3 times. Okay, so if you check the terminology, here there is base, here there is exponent. So if I write it this way, 5, which is the base, exponent is 4, so 5 will be multiplied with itself 4 times. 5 times 5 times 5 times 5, which is nothing but the exponent and its power. How exactly are we going to name it? Now let's do one thing. I will try to move ahead on the topic of square and square roots. So square is basically nothing but multiplying the number with itself. So 7 squared is nothing but 7 times 7, which is nothing but 49. So any number multiplied with itself will give you the square of it. Now let's say if it was 6 square, so what will we get? 6 times 6 is nothing but 36. So I think you guys are aware about what are squares and square roots. Now let's say how do we exactly find square root of any particular number? So guys, can you tell me the square root of 81? Ablam and Valeria.
9.
9. Valeria, do you know how to find out the square root of any particular number?
Oh, I have it in my mind.
Oh, you have it in your mind. Now,
Yes.
let's do one thing. Let me give you a number you might have or you might not have in your mind, okay?
Okay.
I'm not sure. Let me just try giving that to you. 1225. Do you have that in your mind?
25.
Nah.
No.
Did you say 25? Valeria, do you know how to find? Valeria, do you know how to find the square root of any number? Now here we have 1225. No. Okay. Now I am going to teach you how to find the square root of any number by prime factorization method. So first things first, you need to divide this number with any prime number. Okay. Now let's see if this number can be divided by 3. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 5 is 10. So 10 is not divisible by 3, so this 1225 is also not divisible by 3. But we can divide this one number by 5. So 1225, if it is divided by 5, what do you get? 5 times 2 is 10, 2 carried. 5 times 4 is 20, 2 carried. 5 times 5 is 25. Now we need to know which number can you divide. A prime number which you can divide this 245 with it 5 again. So how much do we get when we divide 245 by 5? So I would get 49. Now the next prime number that I can divide 47 is 7. So 47 divided by 7 is 7, and 7 can be divided by 7. Yes. Yes, Ablam, do you want to say something?
Yes.
Yeah, tell me. Now, here we go. This 1225 can be written as 5 times 5 times 7 times 7. Now remember, if you want to take out the square root of any number, if you want to take out the square root of any number, you guys have to form a pair of 2. Pair of 2, bring it outside the bracket. Pair of 2, bring it outside the bracket or the root. So this becomes 5 times 7 is 35. So the square root of 1225 can be found by pairing two numbers at a time. So 5 was there, you just take a single 5. 7 was there, take a single 7. So 5 times 7 is 35. So the square root of 1225 is nothing but 35. Did you guys understand it? Ablam, Valeria? Okay. Valeria, did you understand it? Not much. Okay, don't worry. I'm going to solve few more questions on it. So let me take another number. So I will take Valeria, if possible, can you turn on your mic? We need to find the square root of 8100. Ablam says 90. Okay, Ablam already knows it. But let us try to use the method which we just learned. So Valeria, which prime number, which is the least prime number that you can divide 8100 with it? Which is the least prime number? Come on, tell me. Valeria, do you know what are prime numbers and composite numbers? Yes, it is 3. You can divide it with 2 also, but let's start with 3 right now. So what do we get? 8100 divided by 3. We have this equal to 2700. Now, Ablam, can we divide this number by 2? Yes. So what do we have? 1 times 3, 1 carried, 50. You can just simply do the division in this part, okay? Now, Valeria, tell me a number, prime number that we can divide 1350 with. Yep, you can divide it with 5 also. You can divide it with 2 also. Let's go ahead with 5. Chal. So 5 times 2 is 10, 3 carried, 70. Now we'll take Ablam's number. You can divide this number by 2. So 135. Now 135. Which prime number do you think you can divide this 135 with? Ablam says 5. Okay, let's go ahead with 5. So 5 is nothing but 2 and 7. Valeria, which number do you think, which prime number do you think you can divide this number with? 27. No, you cannot divide 27 with 2. You can divide it with 3. The number that you can divide 2 with always ends with 0, 2, 4, 6, 8. Only even numbers can be divided by 2. And if you want to check it for 3, you need to add the numbers. Like 2 plus 7 is 9. 9 can be divided by 3. So this 27 can be divided by 3. 27 divided by 3 is nothing but 9. Now 9 can be divided by 3 also. 3 times 3 and here 1. So now what am I going to do? and just going to form a pair of 2. 8100. So we have 3 3. I'll take out one number from it. Pair of 2, I got a 2 outside. 5, I got another 5 outside. And 3, I got 3 outside. So 3 times 2 is 6. 5 times 3 is 15. And we have 6 times 15, which is nothing but 90. Valeria, did you understand it a bit more than before? Okay. Now, I want you guys to find the square of 12 first. Come on, guys. Square of 12. Square of 12. Square of any number is nothing but the number multiplied with itself 2 times. Ablam has already got the answer. We'll wait for Valeria. Valeria, did you get what is 12 times 12? The square of 12, which is 12 to the power 2. 12 times 12. So when you multiply these two numbers, you're going to get 144. How do we do it? 12 times 12. Start with the number in the ones place. So 2 times 2 is 4. 2 times 1 is 2. Because I'm moving on to the tens digit, I'll put a 0 over here. 2 times 2 is 2. 1 times 1 is nothing but 1. Add it up. So 4, 4, 1. So 144 is your answer. What is the square root of 81? Oh, you guys already know it. Yeah, Pablam. Very good. Remember the square and square roots from 1 to 20. Which of the following is not a perfect square? Which is not a perfect square, guys? These are just some basic questions that will help you out in getting your foundation strong about square and square roots. Perfect square means what? Like let's say 25 is the number which is perfect square of 5. 36 is a perfect square of 6. Yep, Ablam. Because if you see this 49 is nothing but 7 times 7. 64 is nothing but 8 times 8. 75 cannot be distributed in any two such numbers. 121 can be written as 11 times 11. So this number is not a perfect square. Now similarly, cube and cube roots. So cube is a number which is multiplied with itself 3 times. So if I take an example, 4 cube, that means 4 is multiplied with itself 3 times. So 4 times 4 times 4, which will be nothing but 64. Okay, and cube root. So what do we do? 27. So 27, cube root of 27 will be nothing but 3. That means you need to find a number which is multiplied with itself 3 times. So if you want to understand the process, you can just master the prime factorization method. Let's say if I go ahead with 216 and I want to find the cube root of this. So the least prime number that I can divide this 1, 216 would be nothing but divided with 2. 1, 0, 8. 108 divided by 2 would be nothing but 54. 54 divided by 2 would be nothing but 27. 27 can be further divided by 3. So this becomes 9. 9 can be divided by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. So cube root of 216 would be a pair of 3. Take a pair of 3 and just take a number from it. Pair of 3. So 2 times 3 is 6. So the cube root of 216 is equal to 6. So remember, square root and cube root. You can find both the answers using the prime factorization method, but in square root you need to form a pair of two numbers. In cube root you need to form the pair of three numbers together. Let's move. And perfect cubes are the numbers that are basically cube of some other number. Now let's say 1 is the cube of 1 itself. Cube of 1 is 1. Cube of 2 is 8. Cube of 3 is 27. Cube of 4 is 64. Cube of 5 is 125. Let's move on. So what is the cube of 4? Come on guys, find it. Cube of 4 means the number 4 raised to the power 3, which is nothing but 4 multiplied with itself 3 times, which is also equal to 4 times 4 times 4. Avlam got it right. Valeria? Yes, A, that's correct. Let's move on. So the cube root of 125. Find it, guys. Ablam already knows the answer. Valeria, what will be the cube root of 125? A, that's right. Now identify the perfect cube. So here, let me help you guys over here. So 64 is nothing but cube of 4. 100, I don't think so it's cube of anything. 144 is also cube of nothing. 81 is also cube of nothing. So only 64 is cube of 4. If you want to identify whether it is a perfect cube or not, what do? 144 divided by 2. So this can be 144 divided by 2, 72. 72 divided by 2 would be 36. 36 can be divided by 2, which will be 18. If you divide this by 2, it will be 9. If you divide this 9 by 3, you'll get 3. 3 divided by 3 is 1. So if you want to see if it is perfect cube or not, we can form a pair of 3 over here, which is 2 times. But we cannot form a pair of any other numbers. So here there is only two numbers, 3 and 3. If there was one more 3, you could have converted into a perfect cube. Or you could have said that is a perfect cube number. Now, scientific notations. So guys, if you focus on this scientific notation, so it's very easy. What we need to do, so now let's say I want to write this 23,000. I want to write this 23,000 in a scientific notation. You might get a single question, one question or two questions from this particular topic, scientific notation, and it's very easy. So 23,000. Now, first thing that you need to identify whether this number is greater than or less than 1. So yes, it is greater than 1. And next thing, you have to just take one digit to the left hand side of the decimal. Now here there is no decimal. So let me put over here. So 1, 2, 3, 4. So this will become 2.3 times. Because this number was greater than 1, I'll put a positive power of 4. If the number is greater than 1, you will take a positive power of 10. And the power will be nothing but how many numbers, how many digits the decimal place has moved. Now, if it was negative over here, now let's say if it was less than 0, so 0.00056. Now, what we know the standard form, there should be only one number to the left hand side of the decimal number. But how many numbers are there? Here there is one, but let's say there should be a natural number. So this 5 should come to the left hand side. So what do we need to do? Move the decimal to the right. 1, 2, let's say from here to here, 1, 2, 3, 4. So this will become 5.6 times, because it was less than 0. You take a negative number. Let me solve few more questions for your better understanding. See, here we go. 540000. So you have to convert it into scientific notation. There should be only one non-zero number to the left hand side of the decimal. Whenever there is no zeros or no decimal points, just put a decimal point, take a 0 over here. Now, what do we do? Because this number is greater than 1, let's move the decimal now. 1, 2, 3, 4, 5. So it becomes 5.4 times 10 to the power. Because it is more than 1, take the power as positive. So 5.4 times 10 to the power 5. Did you guys understand it? If it was less than 1, let me take one more example of less than 1. If it was 0.000529, let me make it more complicated. 00263. So let's do one thing. Because this number is less than 1, so we are going to take negative power for 10, and we just need to keep one non-zero digit to the left hand side of the decimal. So let's move the decimal point now. 1, 2, 3, 4, 5, 6. So it becomes 2.63. And how many times did we move? How many places did we move the decimal? 6. So this becomes 2.63 times 10 to the power minus 6. This particular marks are very easy to score. Now, try solving this, guys, and give me the answer. Yep, you guys got that right. Let's move on to the next question. Now, whenever it is already given into the decimal note, like let's say the exponential form, how do we convert into a standard form? So it's very easy. Remember, if the exponent is positive, move the decimal ahead. If it is negative, move the decimal behind. So let's say, because it is positive over here. So what will we do now? I'll just put like n number of zeros over here, and because it is positive, when something is positive, you move ahead. So move the decimal ahead. 1, 2, 3. So the answer will become 1200. If it was negative, now let's say if it was negative, so let me take 2.89 times 10 to the power minus 6. So if the power is negative, you take the decimal behind or in the backward direction. So if there are not much digits over there, if there is, because here there is only one digit, just add whatever number of zeros you want, because it doesn't matter much. 2, 3, 4, 5, 6, 2.89. So let's move. 6 digit is what we need to move back. 1, 2, 3, 4, 5, 6. We have 0.00000289. This is its standard form. I hope you guys understood it. Now we are going to learn in details about rules of exponents. So the product of powers rule. So here, guys, please note this down somewhere in your notebook. I'm going to explain you around 6 to 7 rules which are very, very crucial, and this will help you out for your algebraic expressions, solving equations, exponents, uh, roots. Okay, these particular rules are going to help you out everywhere in algebra. So let's study the first law, which is nothing but a to the power m times a to the power n is equal to a to the power m plus n. So how do I explain that to you? 5, in place of a I am just putting 5, and in place of m I am putting 3. 5 to the power 2. So I can simply write this 5 to the power 3 as 5 times 5 times 5, and this 5 to the power 2 can be written as 5 times 5. So what do we get? 5 is multiplied with itself 5 times. So you can, without doing all this circus, what we can do, just use this law 5 to the power 3 plus 2, which is nothing but 5 to the power 5. So this is how we have also derived this particular law. You can write down this as the example, and we are going to move on to solve some questions based on it. This simple law. So we are going to take easy questions, and in the end of the class I'm going to give you some difficult questions to solve. Simplify the following expression. So here, see if the base is same. So a to the power m times a to the power n. The base is same, the power is different. So what will I do? I'll keep the base as same. I will add the power. So 3 to the power 4 times 3 to the power 2, which is nothing but 3 to the power 4 plus 2, which is 3 to the power 6. Yep, Ablam, the answer is A. Valeria, did you understand this law? This power, same base, different power law. Valeria says yes. Let's move on. I want you to solve this question ASAP. Oh, I already have two answers. That's awesome, Valeria and Ablam. Solve this question fast. Quick! Oh, awesome. Solve this question fast. Awesome. Now, I'm going to teach you the other rule, which is known as quotient of power rule. So now, we just learned if two exponents having the same base but different power are multiplied, it will be added. But if they are divided, then the power will be subtracted. What I mean to say, a to the power m divided by a to the power n is nothing but a to the power m minus n. So how do I derive that? So 7 to the power 3 divided by 7 to the power 2. It's simply basically what 7 to the power 3 is what? 7 times 7 times 7. And 7 to the power 2 is what? 7 times 7. So I can directly cancel this 7 out, this 7 out, this 7 out, this 7 out. What is remaining? Only 7 is remaining. Now without doing much circus, if I just apply this rule. 7 to the power 3 minus 2, because same base was there, power was different, so I just subtracted the power of the denominator from the power of the numerator, and I got 7 to the power 1, which is nothing but 7 only. I want you guys to solve this question. Look at the base. It is same. The power is different. Apply the quotient rule. So x to the power 8 minus 5, which is nothing but x to the power 3. Awesome, guys. That is right. Solve this question. Solve this question. Most of the questions answers are A only. Yep. Solve this question. Yep. You guys got it right. Now, power of a power rule. Remember, I'm just taking some easy questions for you to master the rule. And after that, we are going to get into some complex problems, which I will be solving and you will be also solving after me. So, power of a power rule. A to the power m to the power n is nothing but a to the power m times n. Now, how do I understand whether this rule is correct or not? Let's try to put in some numbers. So 7 to the power 3 to the power 2. So I am not going to apply the rule right away. Let me just try solving the old traditional way without the formula. So 7 to the power 3 will be what? 7 times 7 times 7 to the whole power. And this square means what? Whatever is the base, it is multiplied 2 times. So 7 times 7 times 7 once, 7 times 7 times 7 twice. So if you observe carefully, this is 7 multiplied with itself 6 times. 7 to the power 6. Instead of doing all that circus, I can just say 7 to the power 3 times 2, which is nothing but 7 to the power 6. So that will be your answer. Write down the rule and solve this question first. Very good. Solve this question. Awesome. Solve this question. Mm-hmm. Yep. Now, power of a product rule. Many students get confused with this law. Power of a product. Now, let's say if there is A times B and both of them are raised to the power n. So, what do you do? A to the power n times B to the power n is what you guys do. Now, if it was m times n to the power 6, so what will we do? M to the power 6 times n to the power 6. And it is also vice versa, guys. How do we do it? Let's say if it was 3 to the power 2 times 2 to the power 2. Now look, the power is same. The bases are different. So what do? We keep the power same, but we multiply the bases, which is nothing but 6 to the power 2. That's how you do it. Okay. Now, let us try solving some questions on it. Solve this question first. 3x raised to the whole power 2. Nah, Ablam. Hold on. 3x to the power 2. That simply means it is 3 times x to the power 2. According to the rule, which was a times b to the power n. What do we get? A to the power n times b to the power n. So this will become 3 to the power 2 times x to the power 2. Now 3 to the power 2 doesn't mean 3 times 2. No, it is 3 multiplied with itself 2 times. So 3 times 3 times x square, which is nothing but 9x square. That will be your answer. So option A is correct. Did you understand it, Valeria? 3 to the power 2 doesn't mean 3 multiplied with 2. It is 3 multiplied with itself 2 times. Let's move on. Solve this question. Take your time. It's fine. Ablam got A. You are right, Ablam. Let's wait for Valeria. Do you want me to solve this, Valeria? Okay, here. Remember the law A times B. If you don't see any sign in mathematics, you have to consider it as multiplication. So A times B to the power n would be nothing but A to the power n times B to the power n. So what will I do now? 4 A to the power 3 whole to the power 2 would be what? I'm going to separate the powers now. So 4 to the power 2 times A cube to the power 2. So 4 to the power 2 is what? Not 4 times 2. It's 4 times 4, which is 16 times. Now, if you remember power to the power law, so we need to multiply this. A to the power 3 times 2, which is nothing but 16a to the power 6th power. Did you understand it, Valeria? Yes. Let's move on. Guys, solve these two questions. Answer. Aglan says B and A. Yes. Yep. Ablam, you're right. Valeria, did you get the answers? Mm-hmm. You're right, Valeria. Solve the second one now. Do you want me to solve it, Valeria? Okay. Can you explain the second one? Okay. There we go, guys. A b square to the power 3. It also means a times b squared cube. Now I am going to use this identity. A times b to the power n is equal to a to the power n times b to the power n. Simply b square cube. Now for this particular thing I'm going to use the power to the power identity. So let's say if I take it a to the power m to the power n is what? A to the power m times n. So a to the power 3 times b to the power 2 times 3. So we have a cube b to the power 6. So option A will be correct. Now let's move on to the next rule, which is nothing but negative exponent. So negative exponent, guys, whenever you see something like this, like let's say 5 to the power minus 1, so you will have to take the and reciprocal and you can just make the positive power positive. So a to the power minus n is equal to 1 over a to the power positive n. So let's say if it was like this, 6 to the power negative 2, so you can just take the reciprocal of it and make the power positive. So 1 over 6 to the power 2 is what you will get. Now let's try solving this. So here we go. X to the power minus 4 would be nothing but 1 over x to the power positive 4. Yep, Ablam, you got that right. Let's move on to the next one. Yeah, what will the answer be to this question? 3 to the power minus 2 equals to what? Ablam says A. You are right, Ablam. Can you explain it, Ablam? Hmm. Yep, you're right. So how do we do it? We basically take 3 to the power minus 2 would be nothing but 1 over 3 to the power 2. And 3 to the power 2 is what? 3 multiplied with itself 2 times. So 1 over 9 will be your answer. Yeah, I want you guys to also know one more rule. Please note this down, it will be very helpful. A divided by B to the power negative m will be equal to B divided by A to the power m. If you just take the reciprocal, you can just make the power positive. So you can say 5 over 7 to the power negative 8 would be 7 over 5 to the power positive 8. Write it down, guys, and let me solve this both questions for you. See here, as I told you, if it is like this, a to the power negative m, it will be nothing but a to the power 1 over a to the power positive m, and it also goes vice versa. If it's negative power in the bottom, you can just make it like this, x to the power positive 3. And in this case, for the second question, what we are going to do is 2 to the power 2 divided by x to the power negative 2 would be nothing but x divided by 2 to the power positive 2 by using a over b to the power minus m is equal to b over a to the power positive m. So you can just simply convert these powers x square. You can just individually put the powers to the numerator and denominator. X squared 2 squared, which we have x squared over 4. Okay, now write this law down as well. A by b to the power m is nothing but a to the power m divided by b to the power m. So if it was 6 over 7 to the power 3, so 6 to the power 3 divided by 7 to the power 3 will be your answer. Write it down and then we'll move on. Zero exponent rule. Guys, remember anything to the power 0 is 1. 100 to the power 0 is 1. 100,000 to the power 0 is 1. 1 billion to the power 0 is 1. 1 trillion to the power 0 is 1. Anything raised to power 0 is equal to 1 only. So, try solving these questions fast. 5 to the power 0 is what? Yep. Solve this question. Yep, you're right. Valeria, you're absolutely right. Solve these questions. Ablam says B. Yes, you're right, Ablam. Solve the next question. Yep, Ablam, you're right. It's B again. Anything, any goddamn thing in this world to the power 0 is 1. Now, what we are going to do is we will solve some questions that have appeared in your sample papers. Okay, let's directly jump onto those questions. So I will try giving you 90 seconds first. Then you guys can, like, I will solve it for you. Solve this question. The dot means multiplication. In this particular case. Ablam says A. Yes, you are right, Ablam. Valeria, do you want me to solve this one? Valeria, or are you solving it? Yes, I'm sorry. That's fine. You don't need to be sorry about it. I will solve it. So here we are going to apply 2 to 3 laws combined into this. 2 to the power 3 times 2 to the power 4 to the whole power 2. So first we're going to solve whatever is there in parenthesis. So same base, different power. What do we do? A to the power m times a to the power n is what? A to the power m plus n. So I'm going to do 2 to the power 3 plus 4 whole power 2 remains as it is. This becomes 2 to the power 7 to the power 2. Now we're going to apply the power to the power law, which is a to the power m to the power n, which is nothing but a to the power m times n. So we would get 2 to the power 7 times 2, which is nothing but 2 to the power 14. So option A is correct. Did you understand it, Valeria? Yes, let's move on. Solve this question. Your time starts now. Whatever laws or rules that we have learned for exponents, you have to use those laws and rules only for solving this type of questions. Let me solve this. So whenever you get any question like this, you need to do the prime factorization. 729. So here, because the base is 3, so we are going to get something in 3 only. Let's divide this 729 by 3. What would I get? 2, 4, 243. 243 divided by 3 would be what? 81. 81 divided by 3 would be 27. 27 by 3 is 9. 9 by 3 is 3. 3 divided by 3 is 1. So I can say this 7 to 9 is nothing but equal to 3 multiplied with itself 6 times, which is nothing but 3 to the power 6. And what are they asking? 3 to the power 2x. So whenever LHS is equal to RHS, the base should be equal, which is equal, and the power should be equal. So 2x equals to 6. Now because this 2 is in multiplication with x, you just need to divide both the sides by 2. What would you get? You would get x equals to 3. That is your answer. I hope you guys understood it. Do you want me to solve it once more? Valeria, Ablam, let's move on. Good. Solve it. Your time starts now. Blanc says A. Let's wait for 15 more seconds. Your answer is right, Ablam. The answer is A only. How do we solve this? Apply one rule at a time. 5 to the power 6 divided by 5 to the power 3. Keep this multiplication in aside for now. So here, what am I doing? A to the power m divided by a to the power n will be a to the power m minus n. So this becomes 5 to the power 6 minus 3 times 5 to the power minus 2. So 6 minus 3 will become 3 itself. 5 to the power 3 times 5 to the power minus 2. A to the power m times a to the power n is what? A to the power m plus n. So I'll apply that rule. 3 plus negative 2, which is nothing but 5 to the power 3 minus 2, which is nothing but 5 to the power 1. So option A is correct. Let's move on to the next question.
Okay.
Your time starts now, guys. Mm-hmm. Ablam says D. Okay, that is right. Oh, let me solve it first. So they are saying 2a 2 to the power a equals to 32. It's not that serious, guys, okay? If you see numbers, do not get frightened. So 32, just divide it by 2. What will I get? 16. 16 can be divided by 2, you get 8. 8 can be divided by 2, you get 4. 4 divided by 2, 2. 2 divided by 2, 1. So 32 can be written as 2 to the power 5. 2 to the power a. What does that mean? A is nothing but equal to 5. Let's solve the other part now. So 16, I'll do the prime factorization. Divide 16 by 2. 16 divided by 2 is nothing but 8. 8 divided by 2 is nothing but 4. 4 divided by 2 is nothing but 2. 2 divided by 2 is nothing but 1. So I can say 16 is nothing but 2 to the power 4. So what are they saying? 2 raised to b is equal to 16, which is nothing but 2 to the power 4. So b is equal to 4. Now, Ablam, if you look carefully, a minus b, 5 minus 4, which is nothing but equal to 1. Option A is correct. Valeria, did you understand it? Yep. Last two questions of the class, guys. Your time starts now. See, the options are all with the base 2. So try converting everything into base number 2. Let me solve it. This 4 to the third power times 2 to the sixth power to the power 2. So this 4 can be written as 2 to the power 2, keeping this 3 power as it is, times 2 to the power 6 to the whole power 2. Now, as we already know, a to the power m to the power n, these both are going to get multiplied. So we have 2 times 3 times 2 to the power 6 to the whole power 2. Let's solve it here. So 2 to the power 6 times 2 to the power 6 to the power 2. Now the bases are same, so the power will get added. 2 to the power 6 plus 6 to the whole power 2. 2 to the power 12. Now it's power of power, so we're going to multiply these two things. 2 to the power 12 times 2, which is nothing but 2 to the power 24. That will be your answer. One last question of the class. Your time starts now. Try to get the base of the right hand side as 2. Okay, Ablam, you got the answer. Hold on for 10 seconds, then I'll solve it. Yeah. So whenever you get any question like this, the first thing that you're going to do is do the prime factorization of the number. 128 divided by 2. 128 divided by 2 would be 64. 64 divided by 2 would be 32. 32 divided by 2 would be 16. 16 divided by 2 would be 8. 8 divided by 2 would be 4. 4 divided by 2 would be 2, and 2 divided by 2 is nothing but 1. So I can say that 128 is nothing but equal to 2 to the power 1, 2, 3, 4, 5, 6, 7, which is also equal to 2x plus 1 whole power 2. So first thing that you need to do, you need to multiply these two powers. 2 to the power 7 equals to 2 to the power x plus 1 times 2. 2 to the power 7 is equal to 2 to the power 2x plus 2. So bases are same. So you need to equate the powers. 7 equals to 2x plus 2. Now the first thing that I'm going to do, subtract 2 from both the sides. What do I have? I have 7 minus 2, which is equal to 5, and this is equal to 2x. So x would be equal to nothing but 5 divided by 2, which is not there in the option, but it will be 2.5. Okay, so that is it for the day, guys. We will update you about the next boot camp in our Facebook group, also on our WhatsApp group. So please stay tuned, and if you have any doubts, just ping me up on WhatsApp or my Facebook group or my Facebook profile. So this is your mathematics knowledge coach Vivek signing off. It was pleasure meeting you. Bye guys. Have a good day ahead.
Bye bye.